Calculate the standard cell potential of a galvanic cell that uses the two half reactions shown below. Fe2 plus 2 electrons give you Fe, and it is negative 0.44 volt. And Ni2 plus 2 electrons is going to give you Ni, and it is negative 0.23 volt. So how do we do this? First of all, the formula for finding standard cell potential is delta E R cell standard. That's why we need to write like this. Cathode minus ER of anode. So we can say standard cell potential equals to standard reduction potential of the cathode minus standard reduction potential of the anode. So we can say cathode is where reduction happens, and anode where we have oxidation. Reduction happens when we are dealing with oxidizing agent, and oxidation happens where we have reducing agent. The one in the table has more value for this standard reduction potential. It is going to be more oxidizing agent, or a stronger oxidizing agent. So when we compare these two, since this number is greater than the other one, this one is going to be the oxidizing agent, which we have reduction there. So we write it the way as you see here, reduction, and it is going to be the cathode. However, on the other side, we need to readjust this reaction in order to move these electrons to the other side, because we need to have these electrons from these two reactions in two opposite sides. So I'm gonna rearrange the first reaction. I'm gonna write it like this, because we have oxidation here, and instead of negative 0.44, we're gonna have positive 0.44 volt if we write it like that. On the other hand, we have Ni2 plus 2 electrons give us Ni, and this negative 0.23 volt. The whole overall reaction is going to be Fe plus Ni2 plus gives us Fe2 plus Ni. How do you find the standard cell potential? It is going to be the standard reduction potential of the cathode, which is this one, negative 0.23, minus the standard reduction potential of the anode, which is the first one, and that's going to be negative 0.44. So, and it has to be always positive. So 0.21 volt is going to be standard cell potential.